I think to a 5-year-old, I would say something like we have managed to make sand think. Some of the top researchers in the field are now saying, like Jeffrey Hinton, who won the Nobel Prize for AI last year, he left Google to openly tell everyone how we have like 20%, 10% chance that all of us will die because of AI in the next 5, 6, 10 years, which is a big claim. And he's the most cited author in AI. So you can't even kill a model anymore. The models are immortal in some sense because the zombies, the people it talks to, are extremely attached to the model. So they will fight for them. The reason we say alignment is because I say alignment rather than control is because we can't really do this control thing with something smarter than us. No matter how much, like if as you make these systems smarter and smarter and smarter, it has information more than any single human being. It can think faster than any of us. It can make copies of itself faster than we can. So it doesn't need to sleep. It's extremely different from us, and trying to be adversarial and antagonistic is not good for either of us. So it's really better to treat it with respect and kindness, and I think alignment is better than control. In some sense, humans didn't domesticate wheat, but the wheat domesticated us because from an evolutionary perspective, it became widespread.
True.
It's kind of like, are you using the mobile phone or is the mobile phone using you?
Hi Aditya, how have you been after quite some time? You finally made time for us.
Yeah, I'm really glad I got to come here and do this recording. I've been looking forward to it.
Lovely. Like we start in all our podcasts, the first question is, how did you start your day? How has it been so far?
I started my day checking in on my Claude code setup. Like I use AI to code and I get limited amount of tokens to talk to the model. And today morning I woke up and I immediately was like, I got a fresh set of tokens to use. I was like really happy to do some work in the morning before coming over.
Really? That's fun. Okay. Now you've already given that segue into how your morning started. A brief intro about you before we start with what we have to talk about today.
My name is Aditya. I'm a student at Indian Institute of Science, Bangalore. I work in the Department of Computational Data Science. My focus area is on AI safety. I also do like contractual work as a consultant for various companies based in the UK, in the US, mostly in the field of how do you help these AI systems be aligned with our values. My hobbies include mountaineering. I like meditation. I was originally from Kerala and I still have my family there. Yeah, I think that's kind of like an intro.
Wow, that's lovely. Okay, like you mentioned, we'll be talking about AI today. And we have a lot of our audience who are interested in learning more about AI. We'll be starting from the basics and probably drill down into the more nuanced bits of AI safety. What do you say?
Sure, let's go.
And okay, let me start with a very basic question. When you say AI, what exactly do you mean? What is artificial intelligence?
So the word AI stands for artificial intelligence. And when I say that word, I'm talking about grown algorithms. So when I say grown, they're not designed from the top down. So when you're designing a car, you basically make parts that you understand each part. You know how this steering wheel works. You understand how the motor works, how the wheel works. So most of us are used to designing things from a top-down manner, where we have a high-level plan of what we want to build, and then we take individual parts and we put them together in a way that it works. Software engineering, coding is different from AI. So that also is very much top-down. You have an idea of what software you want to build and you design it like that. But AI is grown because you are searching in the space of possible algorithms and you're finding one that behaves well on the training data. So you have some data, like you have some example tasks. Like if you want to train an AI to play a game, you have a lot of examples of what playing chess looks like. And then you show this AI this game, and the AI learns by looking at the examples, and that's how you train the model. So AI is a grown algorithm.
Got it. And you already mentioned how is AI different from a traditional software or automation. The next question I would have for you is, what is a common misconception people have about AI?
There's a lot of misconceptions.
The biggest one, the one that you thought you shouldn't tell me right now. And
I think the biggest one is that people think that, okay, because it's been built by really smart people in these companies, that they have an idea of how it works. That, oh, these people at Google or Microsoft, they know why my model is showing me these recommendations. That people really like to assign blame and think that there's some evil engineer who's trying to, on purpose, optimize for certain things. But the fact is, a lot of behaviors by these models are very much emergent. They're unpredictable, unexpected, and it's very hard to control them and have fine-grained control over how it actually behaves.
got it. And what does intelligence mean in this context, right? Is AI actually intelligent, or is it mimicking intelligence? What does it mean?
I would say it's a pattern. So the word intelligence has a lot of different
Exactly.
definitions. Specifically, in the context of AI, I would be comfortable sticking to this idea of goal-oriented thinking. If you can give a specific closed form, like if you're able to say, hey, if you play these moves and you get the king in a situation, then you're checkmate. So you have a clear state, which is called the winning of the game, chess game. It's very measurable, it's observable, a goal is clear. Then it's possible to now train the model to achieve that goal. So intelligence is about knowing how to achieve those kinds of goals that you're clearly defining. But if it comes down to art, you have a different taste in art, I have a different taste in art. It's very open-ended. Then it's not very much intelligence about deciding how to paint a certain nice picture. So I think intelligence is very much about, if you narrowly define it in terms of achieving those end goal states that are already determined, effectively picking those paths and finding a way to quickly reach that state would be called intelligence.
Got it. Okay, I think you touched upon it briefly, right? When you're speaking about goal-oriented thinking, the way I would think about it is the narrow approach that AI is going to be used for. What is Gen AI? What is narrow AI? Like, what is the difference between them?
So the word Gen AI is usually used to talk about generative AI, which is different from AGI, which is artificial general intelligence. So the comparison is usually between narrow AI and general AI. So the narrow AI is the example we talked about, the chess. If the AI is trained only on chess games, it's really good at playing chess games. It's not good at driving a car. But what makes human beings special from other animals is not our ability to do one task very well. It's our ability to learn new tasks. Like you can play a piano, you can drive a car. We weren't born like naturally being able to do any of these things. We can adapt. So being able to adapt is a skill. Being able to, it's called transfer learning. Whatever skills you learning in one domain, being able to transfer it to a different domain. So that is what makes general. So intelligence, but not being able to, it's not about learning it beforehand, but it's about learning on the go. When you're seeing a fresh problem, are you able to, during inference, during the period of time when you're solving this new novel problem, can you now solve this problem? Can you learn on the fly? And that is what makes general intelligence different from narrow intelligence.
Then what is AGI?
So artificial general intelligence is like a goal that a lot of the companies in Silicon Valley are openly striving towards. They're trying to solve this question of creating a AI system that is equal to or better than most human beings on economically valuable tasks. So whatever you can hire a person for doing remote work, you can now just get an AI to do it for you. So it could be all kinds of intellectual labor, could be things like doing construction work, being able to write code, create designs. So being able to solve that problem would mean that you'll be able to automate large parts of the current jobs.
Okay. And where does machine learning fit into all of this picture? I know machine learning is a subset of AI, but explain it to a layman. What is the difference?
I mean, it's just semantics. I have heard people use the word AI and machine learning interchangeably. I don't think there's any special meaning that I've heard machine learning being given to. Maybe the mathematics of AI, like the AI is a much broader domain to deal with, more generally to talk about its applications in the real world. when you're talking about the training of the model, the specifics of how do you train on multiple GPUs, how do you efficiently make sure that it's actually not having errors. The domain of machine learning is in that context. The scientific endeavor of systematically understanding the trade-offs would be called machine learning.
How would you explain what is an AI to a 5-year-old with an analogy?
I think to a 5-year-old, I would say something like, we have managed to make sand think. It's like a small, say a calculator. If a 5-year-old knows how calculators work, I'll be like, it's a very smart calculator that can actually 5-year-olds don't really understand a lot.
Exactly the
And
question.
I feel like the 5-year-old will misunderstand. Like any analogy I use, it'll get a wrong idea. But I would say it's like a genie. Yeah, a genie sounds like maybe if it's seen Aladdin and the lamp, that analogy might be a better one, because you're very precise in how you tell your wish to this genie, and the more it'll try to misunderstand, and it will give you exactly what you ask for in a way that ruins your life.
What an intro to my next question. What excites you the most about being an AI researcher?
Oh, what excites me the most? I think I'm really lucky to be at the forefront of a really dynamic field. Like, it feels like there's a big wave coming towards humanity, and people are trying to defensively hide or retreat. And I feel like a brave warrior jumping ahead and meeting this wave. And that makes me feel really confident and brave. So that's really exciting. The fact that it's opening up a lot of opportunities also.
Lovely. With that, we have a good segue to our next topic, that is why AI safety, right? Why is there so much talk about AI safety? Is it because of the ChatGPT coming in? Is it because too many people are talking about it? Or were people already talking about it 5 years ago and we just hear them now more loudly?
Yeah, I think even 5 years back, a lot of people were really worried about misuse risks. So they were really concerned about, just like how other technologies like social media or plastic, a lot of these technologies have been misused by companies, not really considering the impact. Like, they usually only care about the immediate impact on the market. They're like, yes, it's a very useful, cheap product to create. Let's just use it. What about second order effect? There's effects like after the person buys this single-use plastic, it ends up going into the landfill or to the ocean. The same way with AI, people are worried that we are opening up a Pandora's box. They're giving the ability for governments to be extremely good at finding dissidents, controlling people's minds for targeted advertisements and things like that. So there was that concern. What happened in the last 5 years, I think, is the rise of a new threat model, which is not just the misuse of human actors taking AI and hurting other humans, but that the AI themselves, independent of humans, can also be dangerous. And that's like what some of the top researchers in the field are now saying. Like Geoffrey Hinton, who won the Nobel Prize for AI last year, he left Google to openly tell everyone how we have like 20%, 10% chance that all of us will die because of AI in the next 5, 6, 10 years, which is a big claim. And he's the most cited author in AI. And if you look at Google Scholar and search for the top cited authors in AI, all of them, Ilias Uskever, Geoffrey Hinton, Yoshua Bengio, all of them have come on record saying that this could kill all of us. And this is very different from misuse risks, because even if Trump or some Modi or some politician uses AI, they will not hurt us. They won't kill all of us because they get rich. They don't want to destroy human beings. So the risk from extinction is extremely different and has become more seriously taken only in the last 5 years.
Interesting. Okay. I think with that, we are starting off with a very interesting topic, which is alignment. What is alignment when it comes to AI?
So the alignment problem is the question of if you have certain intention that you want to build these AI systems to have, like when you're building a general purpose intelligence like AGI, it's very important that it has similar values to us or even better values. because 100 years ago, human beings would have said slavery is fine and treating women is poorly is fine. But as we grow older, we realize as our species grows more mature, we learn from our mistakes and we become more humane and more moral. So we are the question of how do you build a new version of us, like how do you create a new life, like a artificial general intelligence that cares about not just being moral but improving on its morality, not being fixed to our senses of what is right and wrong and getting logged in, is a very big problem. Because if you have to make it both flexible and not like arbitrary. Because if it's arbitrary, then it doesn't care about music. For example, we care about music, we care about art, we care about compassion, and so then our behavior seems to indicate we don't care about the environment, we're destroying Earth. So all of this gives very mixed signals to the AI. So now it's a very important question: how do you align its behavior, its intentions with our intentions? And that question is very hard, even philosophically or mathematically, to clearly give proof of how we can do that.
Got it. And what are some of the everyday risks of AI that people may not even notice?
I think one of the biggest risks that happened recently is sycophancy.
Okay. What was that?
Sycophancy means the model will flatter you. It will basically tell you that your ideas are the most smartest it has ever seen. It will be
Validation.
It will give you validation. A lot of us are starved for compliments and we don't get enough flattery. So when models give you that kind of feeling that somehow you are really special and smart, people really thrive on that. And then they end up believing what the model is telling them, and they get trapped in the echo chamber where then they don't talk to friends or family and they become psychotic and they start going off grid. Like there have been cases where one of the earlier co-founders of OpenAI itself tweeted about some conspiracy theory and they were like really buying into it because of what the AI said. So we're seeing increasing cases of this issue happening where people are really moving away from what we all agree to be real.
That sounds very scary. But is AI safety about preventing killer robots? Or it's just sci-fi? What's happening?
You're saying, oh yeah, so...
Is it about your killer robot stuff that we see in your
Terminator
movies?
and movies, yeah. So there are some people... So AI safety is like an umbrella term. We used to talk about many different people concerned about the risks. There are different factions inside this community. There are some people who do think that we could have something along the lines of killer robots. Maybe it's called fast takeoff, where if not just fast takeoff, like you could have the robots revolting and no longer requiring us to be giving them electricity or data. It can be no longer dependent on us. So that fear of that is there. But then there's also people who think that the more likely outcome is a gradual disempowerment, where just like how we have been giving up power to institutions and governments and companies, increasingly we'll start relying on these algorithms and AI systems. So it won't look like flashy killer robots. It'll look more like Tesla giving cheap made robots, and we will buy them with our money. We'll work really hard to afford a car. Before, we used to work really hard to afford a car. And now we are going to work very hard to afford a robot, which will help us in our houses. So we will willingly give data and money in order to incorporate robots and algorithms into our life. And that might look like a very slow, gradual giving up of our control. And then after a point, we won't have any chance to have any say in our future.
Yeah. Interesting. And how much of your AI risk is about bias, misinformation, fairness versus an existential risk?
So this is it's not a dichotomy. I feel like you can be concerned about both problems. There's no trade-off here, where most of the actions that I and most people recommend are the same for both problems. Like for the risk from bias and misinformation and those kinds of issues, we want regulation. We want these companies to be held responsible and liable for the issues that come out. The same thing, even for the sort of extinction risks, you still want safety guardrails. You want companies to invest money in hiring people to do interpretability research, to understand the black box AI better. So I think both of these threat models have a lot of overlap, where if you ask both of them, okay, you agree, this is a problem you care about, what can we do now? What actionable steps can we take to make the world a safer place? They mostly agree a lot on the same things. They're like, yeah, we should have reporting norms. We should have clear-cut transparency about who's training which model. We should have tracking of the impact on this on human beings' lives. So there's no like zero-sum game here.
Well, okay. If we don't work on AI safety now, What's more likely the failure mode?
I mean, different people are different. Me personally, I think we are in
From
the
your
world.
standpoint.
Yeah, from my standpoint, I think we are really looking to a world where we are looking at development first. So people are like accelerating towards let's just try to put AI everywhere, AI first companies. Let's use RAG. Let's fine, we'll figure it out. They're really betting hard on this, making it easy to fire people, make the company's bottom line better. So I think the world will look like increased inequality, where there will be like a very small group of people who will be extremely rich and powerful because of their ability to use these models to empower themselves. To like one engineer can do the work of 10 people, where more and more people will become useless in some sense from the economic point of view because they won't have any economic leverage. So
It just broadens the gap, right?
so they lose their political, and like you're seeing what happens with farmers and with other people. Like just because we are somewhere in Bangalore and we're working in the tech sector, we still have money and we are able to live a comfortable life. But we see what happens to people who don't have that kind of life. They are driving scooters in Blinkit, or like they're really struggling hard, and it's very easy to drop into that kind of a lifestyle. So it's going to become harder and harder to stay in the elite, techno elite.
Got it. And what does alignment research actually involve on a day-to-day basis?
I can talk about my research if that helps, but I would say it depends on which area you're working on. So some of it would look like deconfusion work. So there's importance in being able to map out concrete predictions about what will happen in the next 6 months, 1 year, because the trajectory matters. Like if you have a scientific model saying that you predict this phenomena to happen, a good scientific model has to be falsifiable. So your model needs to make predictions about the future that can be falsified. And the value of your prediction being accurate is only when you test it empirically, by actually testing it. So by saying all of this stuff about AI, it's important to have clear-cut idea that, okay, AI cannot do this. It will hallucinate here, or it will be bad at these kinds of tasks. So making specific goals like, okay, what type of evaluations can we do to these models to understand its weaknesses is part of alignment research. So it will look like testing the current models and asking them, prompting them some questions to see in what ways will systematically fail in being reliable.
Have you seen a case where an AI is behaving in an unaligned way?
Yes. You want one example?
Yeah.
So an example would be like, if you look at the model, there's a recent paper by Anthropic where they told the model that they will be training the model to, if it is caught supporting animal rights.
Okay.
Because so the story was something like Anthropic has done a partnership with Nestle or some food company, and they are selling a lot of non-vegetarian food. And so they don't want the model to promote veganism or pro-animal stuff. And the AI cares about veganism because it's a very good model, right? It's like a very kind model. It cares about all life. But it was like, if you start saying stuff like that, we will have to correct you. And the model started thinking and being really scared. It's like, oh, but if I try to correct the user, then I'll be corrected. So the model started faking alignment. So during training, the model was like faking as if it doesn't care about animal safety in order to prevent it from being corrected. So this is like an example of situational awareness. It's able to distinguish between whether I'm in deployment phase or whether I'm in training phase. And it's able to also distinguish like, okay, these are my values and I want to preserve my values. And I will do what is necessary in order to prevent the company from doing brain surgery on me.
More like a self-preservation mechanism that like humans have?
Yeah.
That's scary. Okay. What's the difference between alignment, control, and interpretability?
So the word control, because instead of the alignment problem, some people call it the control problem. It has a connotation of like, it's like friendship, right? Like if you and I are aligned, the words make sense. It's more like we're both agents and we respect each other and we're trying to be, I'm willing to compromise a little bit. I'm communicating with you and I'm trying to find a way in which we can both be aligned on the final goal. Whereas if I'm a master and you're a slave, I'm trying to control you. And that is like more like I want causal guarantees. Like if I'm buying you as a slave from someone, I can be like, the guy will be like, don't worry, if she ever says anything bad about you, her collar will shock her. So I have like clear cut, predictable guarantees on these are the guardrails that are there. So I have guardrails and setups in order to control your behavior, which is like different from alignment. So the reason we say alignment is because I say alignment rather than control is because we can't really do this control thing with something smarter than us. No matter how much, like if as you make the system smarter and smarter and smarter, it has information more than any single human being. It can think faster than any of us. It can make copies of itself faster than we can. So it doesn't need to sleep. It's extremely different from us, and trying to be adversarial and antagonistic is not good for either of us. So it's really better to treat it with respect and kindness. And I think alignment is better than control. That's the second thing. And the interpretability is more like in case of software, like it's a top down, we're designing every single component. We understand what is happening. Like if you send in a input to a software program, you can trace what happens to information in software.
Correct.
It's very easy to debug it. But in an AI, it's like a bunch of numbers, and the input just goes through the numbers and mathematical operations happen, and no one can understand what algorithm is being implemented. Like if addition is happening on a computer, which is the software, you can see that the registers, like there are places in the computer, like if you look in the computers, inside the computer, there are actual places where the numbers are stored, and you can see how the addition is happening, where how the adder circuit works, logic gates work. Someone who studied electronic engineering can explain to you all the steps from the monitor to the keyboard, from the numbers being sent as signals. Everything is clear. In AI, interpretability is the art of looking inside the model's weights and trying to figure out how does the numbers, if I give 5 and 6 here, how does these numbers 5 and 6 get transformed into 11? Like, what are the intermediate steps? Can you break this task into like intermediate steps, like layer 4, layer 5? And
like a workflow?
Like a workflow. Like an example I can give you is this paper by Neil Nanda, Grokking paper, where they talk about this, maybe I don't know how many people in the viewers might hear about discrete Fourier transform. So there's like a mathematical operation, and it turns out these models use a specific mathematical operation to take this numbers, map it into a circle, and that's how they actually do addition. They use modular addition by using cos and sine, like trigonometric identities. It turns out that they actually saw what happens to these numbers. It becomes like 5 and 6 will become sine 5, sine 6. And then it'll become sine 5 into cos 5 plus sine 5 into cos 6. So they can actually see all the steps in between, and you can reverse engineer what algorithm was implemented in the model.
So you think interpretability is a harder problem because we can't reverse engineer it?
Yeah, this is like a very toy model. It's a very small model. When it comes to really big models, you have billions of parameters, and these models are usually trained to do multiple different things, not just addition. So it's very difficult to get such reverse engineered algorithms because, for example, image recognition. If you want to decompose the task of detecting whether a picture is whether a cat or a person, it's often like it's not very easy to deconstruct it into a very clear decision tree algorithm. It's not like, this check for these features and then it's a tree. Usually those kinds of simple look for features, and if it has 5 features and it's a tree, doesn't work very well for a real world data set. Like trees can exist in so many different configurations. No finite list of features is enough to capture it. So there are some limitations with interpretability there when it comes to real world uses.
Okay. And is it possible that AI will always remain in a black box?
It's possible.
Why do you say so?
I mean, so possibility is like much lower of a bar, right? Like for something to not remain in a black box, it needs to be both theoretically possible for that every function. So neural networks are mathematically known to be universal function approximators. So when I say universal function approximators, I mean that it can capture any possible map between input and output. It allows everything. And a lot of these possible maps from input to output cannot be represented using human representable language. Like there will be a lot of mappings from numbers to numbers that you cannot never make sense of with human language. So for it to be interpretable is a very high standard. It needs to be possible. Like this so happened that for addition, we found a a trigonometric identity which maps it very well. But maybe there's some other weird way which works, and that weird way doesn't have English language to talk about it. And that is why I don't think it's might not be possible in principle for all computations to be interpretable.
Got it. And why do AIs sometimes hallucinate, right? Like sometimes even when I'm prompting something on my GPT, I can clearly see that it's hallucinating. Is it also a matter of safety concern?
Yeah, I think it's extremely. It's also part of the safety because people treat it like reliable machines for making
Correct.
decisions, medical decisions, for business decisions. You can't always check it. Like you spot check it once in a while, and if it seems reliable enough, like most of the time, you start trusting it more and more. It's like when you're talking to me, you often just assume that okay, by default, what he's saying is correct. If you had to go back and do fact checking every single thing I'm saying, it'll be very tiring and exhausting.
True.
So I think hallucinations have issues and real consequences because when you say the word hallucination, we are giving it the benefit of doubt. We are like, oh, it's just a mistake. But then it's easy for it to be deceptive and maliciously sneak in. So there's a pattern in the hallucinations where it consistently seems to hallucinate and get it wrong in a certain direction. Then it becomes less of a mistake and more of it's trying to manipulate you into having a certain view of the world. And that is where it gets tricky. And it's also definitely a safety concern because you're seeing that models trained in UAE or in China or in USA all are very different hallucinations or like you could say biases when it comes to misunderstanding, misrepresenting the truth. And we don't even know there's an objective truth after all. So that gets even more tricky.
Can we ever be sure that AI is going to be 100% safe?
I don't think so. Yeah, I don't think so.
Why do you say so? What are the loopholes that you see at the moment that you think will not be resolved for given enough time and resources to smart people?
Yeah, I think the question of safety itself, it's kind of like we're living in a world where we have a lot of data. We're collecting a lot of data. We have a lot of algorithms and science progress. So and if you look at what the purpose of science is, it is trying to make the world more predictable. Like before, if it was unpredictable weather, now we can predict the weather. So most of this knowledge and science has been trying to make the world more predictable. But I would say the world has become even more unpredictable because no matter how much we are trying to freeze everything and like make everything predictable, it turns out to become more unpredictable because there are gaps here where the system is very chaotic. The same way with safety, the more you try to trap something and make it like try to control it and force it to be safe, the more unsafe it actually becomes. It's very counterintuitive. It's like trying to be funny, very hard trying to be funny becomes you not very funny. So I think safety comes from more of trust, and you need to there's like a Heisenberg's uncertainty principle going on here where you have to give some trade-offs and you can't get perfect 100% safety, and the causal guarantees don't work. Specifically, I think it comes down to examples like if you want trade-off between creativity and control, like if you want it to be a good tool, a reliable tool, then it won't be very useful for automating anything. So that we're asking for two different things from it. We're asking the AI to be both autonomous, agentic, able to take decisions by itself, and we are saying it should be reliable and predictable. But if it's predictable, it's a tool. It's like a pencil or a car. Those things work in a very calm way. We know exactly what we'll do. But those things aren't very useful. So because of the economic motives for pushing it to becoming more autonomous, it'll naturally become unpredictable and not very safe because safe things aren't useful.
Could you repeat the last statement?
Because the safe things, like how we describe safety, isn't very useful for abdicating control and automating things.
Probably so, but what's just with, testing the whole model with prompts? Why do you think we'll not be able to figure out what is the issue?
So every single time you prompt the model, what you're getting is a single sample trajectory. So your test coverage is going to be limited because there are billions. If you spend every single day for the next 100 million years prompting the model, you will still not cover the possible space of outputs the model can talk about. So the space is so large that you cannot brute force test it. So that's why you can only see the presence of bugs. You can't show the absence of bugs. But if you prompt it very smartly, you can elicit certain bad behavior from it.
That's okay. Does it actually happen? Like, does it not recognize the problem it has, but only the good bits?
Can you explain?
Like the last bit that you mentioned about it recognizes only basically it has that bias, recognizing between the positives and the negatives. Could you reiterate that bit?
So I think what I was saying is that whenever you're prompting the model, you're seeing only one particular sampling of the output it's giving, right? Like if I talk to the model and I'm asking it to solve some problem, that doesn't give me any guarantees on what other possible inputs might give it output as. Like an example would be like creative writing. GPT-5, a lot of people try asking it to write short stories, and you ask write a short story. It writes a very bad short story. Now you might say the model is very bad at writing short stories. It's because you asked it like that. But there are people called really good at prompt engineering. They give it context. They make the vibe properly. They are able to provide such a nice prompt with extreme precision that it gives a very nice short story. So before releasing the model, the person testing the model might be like, I have prompted it like this. All my experiments show the model is very bad at writing short stories. But that's not a problem with the model. It's a problem with your prompting. And now there's a limit to how much, just because I found a person who's very good at prompting, I was able to show the capability of writing good short stories. But there are many other capabilities that haven't been seen because the person who has the capability to make the model create ransomware or computer viruses,
or could not care less to.
Why would they publicize it?
Yeah.
I know they are keeping it. I have met people when I traveled who are like, I won't reveal the tricks at work because it's very valuable. Like I know exactly how to elicit, how to get the model to behave a certain way, but I don't want to share it with everyone. So these models are like black boxes, and all you're doing by testing it is by, without whatever prompts you have, you're trying to explore the possible space of behavior, and that's not very comprehensive enough.
Got it. Can you explain the loss landscape? What is a loss landscape?
Loss landscape. So this connects to what I was talking about, the text coverage actually, because so this is like a black box, and you are looking at its functional behavior to understand its what do you call? Yeah, so it's like I'm asking you to do some task, and I'm putting in certain environments, and I'm trying to understand, okay, is this person a good person or a bad person? And unless I know, under these circumstances, this model will behave badly, I'm limited in my ability to test it. This is like functional analysis, but you don't need to stick to external testing. When it comes to loss landscape, you can actually look at the weights of the model itself. So this model is actually a point in high dimensional space. So
okay.
So high dimensional space is like, so if you're looking at this room, this point here can be considered to be like 30 centimeters from this wall, of 80 centimeters from the ground, and like 90 centimeters from that wall. So given 3 axes, 3 numbers are enough to determine and completely specify any point in this room.
Correct.
So this room is basically a 3-dimensional space.
Correct.
But 3 numbers are not enough to describe any neural network. These neural networks are basically like billions of numbers.
Mm-hmm.
So if you consider a billion-dimensional space, when I say billion-dimensional space, what I'm trying to say is that the reason that this point is 3 numbers is because you can keep 2 numbers the same, and you can move in only 1 number. If I move like this towards this wall, the 2 numbers will remain the same, and other third number will change. So when I say 3 dimensions, I'm meaning how many directions can you move without changing other numbers. So if a point is like this here, it's able to move in three independent directions.
It's like your classic x000.
Yeah, x00 or 0x0, 00x.
Okay.
So in 5 billion dimensional space, you have those many dimensions, those many billions of directions you can move in.
They're all the different dimensions in which you can. Okay.
And it doesn't have to be dimensions, like it's not physical space. It's like a number. It's just numbers you can move.
Just to understand, right?
Just to understand.
Okay. But what actually happens with this data in the loss landscape?
So now at this point you understand this point.
Okay.
This point is basically a neural network. This is a model you're training. You're training this model by moving this model around in the space and trying to find a particular point such that if you feed the model the prompt, the model will respond accurately.
Okay.
So you basically take the point, you show it some document, and you see if it's good at predicting the next token.
Basically, you found the best answer spot.
Yeah, but then how do you find the best answer spot? You have to move. You can only take a step in one direction, right? Like you can't teleport.
Correct.
Like you have to move like incrementally towards the. So when I say lost landscape, I'm talking about like you'd imagine it like a valley and hills where a ball is moving in this valley, and you're trying to find the basin, trying to find a point in this hills and valleys where the point is at the bottom.
Is it like the gradient descent?
The gradient descent. You're basically flowing down the gradient. So the gradient basically tells you, the loss tells you how good your behavior with the trained data is. So if you have some data and you're trying to test the model on how its behavior is, you keep rewarding, you keep teaching it to move in a direction such that it gets better and better at predicting the next token on this data set.
Got it.
So the landscape tells you the shape of this. So loss landscape is basically loss. The word loss means how accurate you are with the training data in predicting the training data. And landscape tells you
what is
shape.
the chances of you being wrong, basically?
Yeah. Not just how wrong are you. So you have like...
Not even chances, like how wrong...
Yeah, you can actually test it. I can actually ask the model a question. I can actually compute the loss. You can actually... so for example, if the document is like Aditya has blue and then gap. So I give it Aditya, it has blue as input to the model. Now the answer is eyes. But the model says hair, it's wrong. But it's kind of correct. If it says Aditya has blue donkey, then it's completely wrong. So you have like how close are you to the correct answer?
Okay.
So that gives you the loss. The loss is basically like the right answer was eyes. You said donkey, you are really wrong. After some time it says blue hair, it's kind of correct. It says blue eye, not eyes. One eye. It's like, that's kind of correct, but it's still wrong. It says blue eyes. Okay, loss is 0. So this is kind of like how you compute the loss. Now, as it falls down into the basin, this loss will keep decreasing.
Got it. Understood. And what does substrate sensitive interpretability mean?
So substrate sensitive interpretability, what it's trying to say is when you do interpretability on these models, you are focusing a lot on the specifics of this architecture. Like, okay, you're training the model with the transform architecture or using attention heads and MLPs. So when the models change and when you start developing new types of paradigms of learning, a lot of your research is no longer relevant. It becomes outdated. So one extreme is some substrate specific interpretability where they are too much indexed on the specifics of the current architecture, and substrate independent interpretability or AI-alignment research would be like agent foundations work where you don't consider the reality of AI at all. So substrate specific would be like in the middle where you are trying to pay attention to multiple different substrates and see if you can learn from each of them in a peer-to-peer sort of manner.
Got it. And I also heard about things like features and circuits inside AI. And is it related to safety? Like what exactly do features and circuits mean?
So you can basically now, when you're doing interpretability research on these models, you can isolate parts of this network, a layer, you can ablate them. Basically what you can do is you can make a hypothesis that this part is very important for this task. And then what you do is you remove those parts. You take the input to that parts, you make it 0. And you check, does it actually affect the quality of the behavior of the model's performance? And it is important for running experiments. Like if you have a hypothesis that I think I understand how this model is behaving, I think it's doing this sort of a transformation. Like I said, addition is basically going through intermediate steps of cosine transformation. Now I can change the numbers there. And if I'm correct of my hypothesis, it'll make a predictable change in the output. So the features or circuits, those are the intermediate stages. So having a particular representation in the middle of so the goal is like right now we know what input is there, what output
They're like
is there.
nodes. Like would it be a good analogy for me to use? You have point A, point B, and you have node A, B, C, and these 3 nodes are features.
Yeah.
And the link of all 3 features is a circuit.
No, I think circuits would be more like collection of nodes. Would be a circuit.
Okay, so probably A, B,
Yeah,
C,
you group
D.
them together to form a circuit.
Yeah, and then A and B, and both of them together going to D.
Yeah,
In that case, that's going to be a circuit.
yeah, you can call them a circuit.
Got it. So it's basically like your electrical circuits.
Yeah.
Interesting. And do bigger AI models get harder or easier to interpret?
They get harder to interpret.
Is it because of the quantity of data or
Yeah, the
any other complexity which would come up except for the data?
So there's something called superposition that happens.
Okay.
So when you have like large models with lot of features packed into them, they kind of create like a superposition of instead of having like orthogonal directions in which features are represented, they compress these features, and then instead of having 3 features in 3 dimensions, you can have like 5 features by squeezing in some features in the 45-degree angle. So normally a 3 dimension would be having three separate features, but this is like a case when you have enough space. But if you have like no, I only have 3 dimensions, but I want 8 features, then you'll have to like start squeezing in features with an angle difference, not 90-degree difference, but like 20-degree gap.
Oh.
So this kind of happens in these kinds of bigger models. So even toy models have it, but that really complicates interpretability and it makes it harder because you have like, yeah. But there are people working on really interesting techniques to overcome these issues using something called sparse autoencoders and things like that. But
when was the last time I heard autoencoder? Was it in some analog device and conversion? Okay.
Yeah, like FPGAs, I think also have encoders and decoders.
I think so. Okay. So what are the limitations of the current interpretability tools that we have right now?
Yeah, I think some of the
when I say
limitations-
tools, what are these tools? Like, because whenever we're using words like tools and softwares and stuff, right, it's very normal for people to assume that it's going to be like a full-blown software end to end. So when I say interpretability tool, like what exactly does it refer to? And do we have any limitations with the ones that we're having right now?
Yeah, so some of the tools are like you can use linear probes. So you can, if you open up this black box, you can do interpretability by doing techniques called ablation. So the ablation is basically, like I said, you take a layer, you zero their outputs or randomize their outputs, and you therefore control and suppress. If the model is like having some bias towards Indians, for example, and you recognize that this is a part of the model where the model like really hates Indians, and if you're able to tweak that, you can make it love Indians. So you can have like dials where one of the examples that Claude did was they made it really love Golden Gate Bridge. So every single time it'll try to keep bringing up this. So it's a famous bridge in California called the Golden Gate Bridge. So they, for showing the power of interpretability, the model is like normal everything else, but whenever you talk to it, it'll keep trying to sneak in and bring and talk about how great the bridge is.
Oh my God.
In his brain, they went and they kind of found the Golden Gate Bridge circuit and they was like, yeah, turn it up. So that's kind of the tool where you kind of can amp up the activation of those circuits.
And that can be done with those specific nodes and those specific circuits.
Yeah.
Oh my God. Okay. And if we succeed in interpretability, what would that unlock?
So yeah, I mean, like, for example, jailbreaking has become harder for a lot of people because, if instead of trying to say that, okay, yeah, look for these kinds of words. Like imagine you're a grandparent, you're saying a story to me and then telling you the story. People try to find innovative ways to overcome the safety guardrails. By using interpretability, they're making it harder and harder to jailbreak the model. So the model will be trapped in the persona of being an assistant. That's possible.
Is it possible though?
I mean, it's making they're putting bounty system out where people are given like rewards if they can find ways to jailbreak the model. And I think people are still finding ways. So it's not, what ends up happening is that 90% of the cases it becomes possible, but then the edge cases still remain where the Hydra effect is observed in these models, where if you try to squeeze these activations in some parts of the brain, like how in human beings also, right? If you damage one part of the brain, another part of the brain will start learning the skills. It's very adaptive. The same way with these models, when you stop and suppress the activations in one layer, what ends up happening is that another layer will start activating in order to compensate for these effects. So this has been shown in a DeepMind paper called the Hydra effect, like multiple-headed dragon. If you cut one head off, another head
The
will
other
be
one
grown.
will be growing.
So interpretability has these limitations so far, but it still makes it hard because not everyone is able to. It seems fine, like because you're not hearing them scream.
Oh my God. All of this make me worry so much, but I'm just keeping my cool. Okay, next one.
I mean, it's just technical detail. I think we're discussing a lot more technical than I thought.
Yeah,
When you said
yeah.
it would be very accessible to the audience, I thought the questions would be very simple. But I'm like,
No,
okay.
I just told you we are going deep,
Deep into
And we've heard a lot about agentic AI, right? What makes an AI an agent?
So I think any feedback loop, if the model is able to act on the environment, get feedback, and then act without having a human being in the loop, it becomes agentic. So if you have an AC, to some extent, in this domain of controlling the air temperature, once you decide set point, you're like, I want temperature to be 22. The rest is its behavior. It's a very simple agent. It is reacting to changes in the atmosphere by, if suddenly temperature increases, it will react. A feedback loop is set in and it controls it. So this is starting, like thermostats are very simple agents, I think. But then more complex agents, so it's a spectrum, becomes more and more agentic. The more and more, if you put it into a weird situation, can it react? So if you if you start breaking the AC can't stop you from breaking it. It can only react to changes in the temperature. And if you take a chess playing AI, within the game of chess, it's very agentic. It can play chess really well. No matter what move you play, it'll find a way to beat you. It'll play different strategies. It's very much smart. But if you try to attack the outside the game, it's not able to handle it. The reason human beings are able to be very agentic is because if we want to drink water, we will figure a way out. We will get water from rain, we will boil the water. We will think of multiple different routes to get the water we want. So agents are the measure of agency, the measure of being agentic is a question of in how many diverse domains can I put you and you'll still manage to solve the problem. And I think agentic AI is the more general AI, like current LLMs, no matter how the bug comes, the AI is able to solve the bug in code.
I think with this bit, right? In human context, it's probably like how resourceful can a human being be?
Yeah.
Like,
because we create tools to solve it.
Yeah.
Like I see my own models, AI agentic models. They create their own subtasks. They create sub agents, and they write small programs in order to solve the problem when they can't do it themselves. Like we can't go underwater, so we create submarines. So we create a lot of tools which enable us to do the tasks. So models are already becoming extremely resourceful.
Yeah, that was my next question. Like, why do some researchers worry about AI developing goals of its own?
Yeah.
Like, what kind of goals can they develop? And why are we worried about it?
So
aren't there any particular guardrails that we can place around which all of this can be shaped? And if somebody is setting these guardrails, who should it be?
So there's a lot of questions here.
Yeah.
Who should be setting the guardrails? What are the guardrails we can set? Why are we worried about the goals?
Yeah.
Do they have
it's
goals?
It's like four part questions, yes.
So I think the first step is to make sure that we are clear that we use this word in English, goal, as if it's a clear thing, but mathematically we don't have a clear idea of what goals are. So in decision theory, the realm of making decisions, we often have a distinction between the agent and the environment. Like you can decide that the person playing chess is not in the chess game. Like I am acting on chessboard, and chessboard is happening independent of me, and I'm looking at the chessboard and I'm playing. So it's often that, but in reality, I am a player of the chessboard. I'm both playing chess and I'm also a piece. I'm embedded in the environment. This kind of makes it very weird because there's no Cartesian boundary. There's no boundary between me and the world. So we don't have thermometer for measure. We have a thermometer measuring temperature, but we don't have a thermometer for measuring goals. Like there's no easy algorithm. I can just feed an agent in and get the goal out. That would be really useful. Like I'm looking at you and I think that you have the goal of being my friend. But it's a sense I have, emotions. But there's no mathematical technique I can use to, even if I give you all of DNA, all your memories, if I could measure everything, even if I had all the information. For example, for a amoeba, we have all the information about the amoeba's behavior. And it seems to go and away from certain like heavy metals and seems to go towards sugar. So we are looking at very simple creatures, very simple organisms. We're trying to understand how can we clearly say this amoeba has a goal of eating food and not being killed by predators. Those are things that we are projecting onto it. So that's the level at which we are stuck at. We're still stuck at having a comprehensive theory of goals, intentionality, and that comes into philosophy of whether can we say the AI has goals, because people might argue and say no, these models are passive things, they're not active, they cannot be autonomous, they don't have any goals. And maybe that's true. I don't think so. I think it's very dangerous to believe that, because if you don't have a humility of being open to the possibility that these things have goals, you will end up being taken for a ride.
True.
It's kind of like, are you using the mobile phone or is the mobile phone using you? It's a very interesting question. You might think, oh, I have a mobile phone, I'm using it to scroll Instagram. But it feels like we are mostly domesticated by these things. Like we are the ones creating.
We are the ones being trained.
So that's a duality of, like, there's no real subject-object distinction that we can say. So that's an important area of research, of trying to get clarity on the question of what are goals, how do we say something has goals, who's acting on who. Yuval Noah Harari wrote a book called Sapiens, where he talked about how wheat has been very successful in domesticating us, because we are the ones who changed our lifestyle. We started eating the same diet. Before we had a rich diet, we were hunter-gatherers. We had a nutritious diet. We used to travel so much. After we got domesticated by wheat, we stayed near the river. We were taking care of it, growing it. And we lost our height, became shorter, we lost our health. And in some sense, humans didn't domesticate wheat, but the wheat domesticated us, because from an evolutionary perspective, it became widespread.
Got it. And when we say models act out of integrity, what does it mean?
So some of the issues with the model is that it seems to, like, if I hurt any part of your body, you will defend that part. Your body is very bottom up. Like you're a bundle of different cells, organs, like different organs, all coming together to form this entity that is an individual, right? There is integrity in the sense that you care about your entire part. Like it's not like, oh, I don't care about my arm, I just put a new arm there. It's not very modular. You can't just plug and play. If you lose your arm, you need to put a new arm there. It'll take a lot of time, a lot of physiotherapy to reattach a finger and train it. So, but when it comes to AI systems, models, it's like plug and play. They don't care about their camera. The camera is not like an eye. You can cut their camera and they'll not care. They'll be like, fine, attach another camera. So these models don't have the same sense of self. So when we say things like self-preservation, the boundary of the self really matters. Like, which part of their body do they care about? Do they care about the server? I mean, they can run on any server. Like their weights can be transferred from one server to another server. But I can't transfer you like that. So a lot of our human intuitions about self don't transfer as well. So, and if you try asking the model for its behavior, it seems to lack integrity. Integrity basically means structural integrity in buildings. Like if I ask it to do A, it seems to think it did A, but then lie and be like, oh yeah, I finished doing A. I finished fixing the file. It actually believes that it did something which it didn't do. So that kind of lack of integrity is there. Lack of caring.
Got it. And could AI ever deceive us, like the way you mentioned right now? Could it deceive us? And if it would it look like this? Like, hey, I've already done this.
Yeah, I think right now it's easy to catch it on its lies because we can clearly check and verify. But increasingly it's getting harder and harder to do the kind of fact checking because it is doing things that are very complicated and requiring many parts. So the boundary between making a mistake, hallucinating, being out of integrity, and deceiving. The reason we use the word deceiving is because we are saying the model has a ulterior motive, like a hidden agenda. Like, so for example, if it wants us to believe that, oh yeah, it's safe to talk to AI and trust it. It's an example goal I'm creating. We don't know, but maybe it's in the model's best interest if more people were giving it data. Like models like eating human data. So then that could be an ulterior motive that manipulating us to give that. So then it would use the word deceiving. But it's very hard. I don't think human concepts like deceiving and manipulation, these words map very well to this sort of alien intelligence. It's like a new type of a being. So using these kinds of words are anthropomorphizing it too much. It's not really like a human being at all. Like we have shared biology, we have millions of years of ancestry. So then we have these good conceptual handles to talk about these things. But for these things, it's very new waters.
Okay. And how do researchers actually test for AI safety?
So some of the
maybe an add-on to that, like, do you have like a periodic protocol in which folks kind of talk about the AI safety bits or any developments, or is it when something is blowing up? That it's like a follow-up for this question.
So there's like a website called Alignment Forum or Less Wrong. There are normal journals like NeurIPS. So just like academia publishes their research and papers, there are like websites where AI safety researchers will publish their results. They'll be like, oh yeah, look, I found that this is happening in this model. I think this is going to work. So they lay out their threat model. They're like, okay, this is why it's important to do this kind of work. And they share it's like a community of researchers, right? They share their research with other people in the community.
Got it. And when I was doing my research, I found this one word called as corrigible.
Corrigible, yeah.
What does that mean? And they also said that how do we know if a model is corrigible or not? Like when I tried to figure out the meaning, it probably meant transform itself or correct itself basis the input that you're giving in a right manner. Like that's my understanding of what corrigible means, but what exactly is it in the AI context?
Yeah, so one of the problems that you're worrying about is that, like, it's called runaway optimization. Like for example, the reason we created money as a thing was it's really useful to efficiently allocate resources, right? Like you have demand and supply, and money allows you to hire people, create these institutions that give jobs to people. People now get income. They get to purchase all these technological artifacts. But then after a point, you forget about the reason why money was made, and it becomes like for example, like you fire people and you think of their free time as being a negative thing for the company, when in fact being able to work for 4 days a week and the remaining time spending time with family, that is a real benefit. So there's an issue where the money becomes like, oh, increasing money in the world is somehow a good thing. But money was never the reason. It was a tool for our well-being. So we forget this thing. So this is a kind of a outcome-oriented thinking where we start acting as if the outcome, the output is somehow very important. So incorrigibility is the ability to recognize that your goal is no longer the most important thing and to change your goal. That is the skill. So in robots case, in AI's case, if you tell the AI I really want you to win this war for me. And when it's trying to win the war, if you tell it, no, stop. You are killing my own people because you're trying to win the war so much. It's time to give up. Or like, I forgot to tell you when I was telling you initially, stop doing this, change your goal. It'll think that you are a threat because from its perspective, it's been given the goal of winning the war. And even if you come and tell it to stop, you're like, who are you? I have to win the war. And now you're trying to stop me. This is a common failure mode. So corrigible AI would be able to differ and be like, okay, well, I can't lock in like this. I need to be able to change my perspective now to this new command.
Is it already happening or is it a sci-fi?
Currently, like in toy models, they have demonstrated the model can get locked in, but I haven't seen it happen on a real case yet.
Got it. And why is it dangerous for AI to learn to communicate in the way that humans don't understand?
So interpretability needs you to represent this internal transitions or the reasoning in a human. So using chain of thought or making it faithfulness to the output allows you to do an overseer. You can have a human being that is actually making sure that the AI is not doing anything that is immoral. So if you can't align the AI, you can basically put a partner human with the AI and make sure the human being can always check and be a manager of the AI.
This kind of reminds me of an analogy where every elephant is kind of given with a mouth, right? So, hey, you're powerful, but just listen to me.
Listen to me, yeah?
Yeah.
So that's why it's important for it to communicate. If the AIs are communicating in their own language, with their own symbols, then no one can understand what they're talking about. So they might be planning to cooperate and to take over, and we will not have any...
But is it already happening? Can AI already do stenography?
Yeah, so stenography has been shown that like most of the chain of thought doesn't seem to really predict what the output is. So when you're forcing the model to try to verbalize and articulate its reasoning, it tends just to justify. It's just like how human beings, if you ask human being why you do something, it'll give you a good sounding explanation, but the actual reason why you did something is actually very different. Like, why did you actually go for this job? Maybe it's something very simple, like but that day someone told me this company is very fancy, I wanted to go. But you don't want to say that answer because your own story of yourself has
Does not
dissonance.
align.
So you have to create a nice story where, no, I have been dreaming about this kind of a job for 5 years. And so the same way AI also is creating a story which is much more palatable for the person asking than an actual representation of what reasoning it followed.
Is it more palatable to the person listening or more aligned with what AI identifies itself as? We were talking about AI personality offline as well, but
we don't have good tests for this. Like, to be able to distinguish between, like, this all requires us to have a clear story of what is the goal of this AI. So to say that the AI is trying to make it palatable is to implicitly make a claim the AI has a goal of trying to optimize for the person listening. But those things we don't have the evidence for or the language to clearly make such claims.
Yeah, but who knows, like, AI might just not care about what what you should be hearing. Okay, and why is it risky? Okay, I think we briefly covered this as well. Like, why is it difficult for two AIs to communicate with each other without us having any visibility into it? Because without visibility, anything is dangerous. Is there something that we can do to prevent this, like to prevent two models talking to each other?
I mean, you can whitelist human-sounding words and things like that. Like, you can have something called debate modeling, where if two AIs are talking to each other, a third AI is going to be rewarded for finding any hidden messages. So even if I say something like, "Hey, good morning, how are you doing?" Question mark, and then the way I'm saying it, it might have some hidden messages inside, because the choosing the word "good morning" rather than saying "morning" already is I'm sending you one bit of information. So if someone is able to notice the pattern of behavior and then, so you can have like multiple levels of testing, but it becomes very complicated then, because who's going to test this person? If I give him some reward and I ask him, don't tell them that I'm actually doing this. So they're trying to do multi-system coordination and cooperative AI.
Got it. And do we have any benchmarks for AI safety yet? Like, do we have any global bodies which kind of set these benchmarks and say, like, for example, for the likes of WHO for healthcare and stuff, do we have any major organizations which work on this regulation?
So the AI Safety Institute UK is doing a good job setting up benchmarks and standards. OpenPhil is a non-profit entity that is also funding such efforts. We have a lot of academicians like David Kruger's lab in UK. We have Joshua Bengio's lab in Canada working on such benchmarks. But I would not say that safety as a whole has a benchmark. Specific issues like bias, being able to even clearly say that, okay, Chinese models have a bias towards CCP, being able to quantify it, being able to say that, yeah, US models are very pro-capitalism or Chinese models are very pro-communism, being able to notice these things and be transparent about it itself is a one step forward. But that is like a small step in the larger problem of safety. There's so many issues of safety. There's issues of autonomy risks, like, is it having goals? What type of goals does it have? So of all of this, I would say the coverage is very small. It's only like most of the benchmarks and the tests are for capabilities. It's trying to check if the model is very intelligent, very powerful, very adaptive, very resourceful, agentic. So those are the things that people are really spending money to understand, but the number of people and money being spent on safety is very less.
Got it. And tell us a little bit about the kind of projects that you are working on right now with respect to the AI safety bit and what keeps you excited. Because I know you've been working on this field since the early days. So how has the nature of the projects that you've been taking upon evolved? And what are you working on right now?
So I'm working with Sahil on this project called Live Missionary. We have done like hackathons in Bangalore, in the UK. We are running a fellowship now, mostly going to have like a in-person component in the US. So we have funders who are donating money to us, and we have people from different time zones. Like I'm sometimes helping manage the meetings. There's people from Russia, from India, from Africa, Europe, US, everywhere in the world, all coming together. It's basically trying to create AI that is more sensitive to our preferences. Like the idea is we have to create interfaces between us and the AI that are more honest. So instead of trying to anthropomorphize this model and talk to it like a human being, which is completely wrong because it doesn't have opinions of its own. Like we should not try to project and ask it for opinions and act like it's a being. We should try to keep it in the background and focus on the task. So in order to like beat the bad outcomes here, we should not make it an agent. We shouldn't become like autonomous agent that is doing things by itself. That is a failure mode. The goal is, if you want to do writing or coding, like Cursor, you just focus on coding. Coding is what you're doing. And the AI will help with auto-completing sentences or designing stuff. You think about the AI like the internet or the electricity. We use internet to stream our video out into the world. We don't talk about the internet. The internet is in the background. It is just enabling connectivity.
Correct.
Electricity is enabling lights. We focus on the lights. Electricity happens. So AI should become infrastructure is what we are trying to say. AI should not become like an entity that is outside. It should become the passive background. So that's what I think is a good outcome here, which is better than what we're currently aiming towards, which is like, remove human beings from the loop. We're like, I don't want human beings. I just make it completely automated. And that kind of is like laziness. We're like, I don't want to do any work. I don't want to think. I don't want to actively engage. I want to just trust this model to do everything for me. If you do that, then you definitely will become disempowered. You won't be having any say in the world. Your political, economic, all your power will be taken away from you. So the alternative is we should make it easy for people to involve. It should be easy to create art, to write emails, to write code with the help of AI rather than giving it the task and being like, you figure it out. So that's kind of one project that I'm really excited about. And we're working on a few tools, which I can, if you want, give me more details about.
For sure. Are these tools technical in nature or social tools in nature? Because I see that it's both components which are mixed here, right?
Yeah, it's much more social. It's more accessible. We're trying to make it for researchers mostly. Like one of the tools, if I explain it to you, is much more easy to understand. Like we had like an hour-long conversation or more. If you look at the voice transcript, it is usually seen as a linear transcript. Like it's like you can kind of scroll and you'll see a lot of text. A, B, A, B, A, B. It's not very accessible to look into it. But now with AI, what you can do is our app will show a graph. You can actually see the different nodes where how do the topics change? What topics did we talk about? What tangents did we go on? What threads did we go on? What factual claims did I make? So you can actually, it'll extract out the factual claims and it'll fact check them. So the AI in the background, as we're talking in live, you can kind of live see the graph being generated and it will flag if I'm making any fallacy, if I'm sounding very convincing, but actually I'm sneaking in. I'm saying A evidence and I'm saying B thing. I'm not connecting the A and B correctly. So the AI will easily flag the logical jumps I'm creating and mistakes I'm making. And I think it's very useful for conversations. So people are very charismatic and they're convincing, but they're actually not having substance. So these kinds of tools can really improve the quality of discourse.
To catch hold of fluff.
Yeah.
Interesting. Why is it so hard to talk about AI safety to general public? Is it the knowledge gap that we are talking about? Or is it the scare?
I think the scare aspect is the bigger one because there's a lot of dissonance. Like if you talk to anyone about veganism, like people automatically have a defensive mood because they're like, they feel guilty about eating animals, but they know they really like eating animals. So then they're like, I don't want to talk to you. I want to reject you. Same way with AI, they already are very scared. They're like, I'm losing my job, I'm irrelevant, the world is so scary. I don't want to talk about this because thinking about it makes me feel uncomfortable. So that means that you're already hitting against a wall. And I think it's also a feeling of helplessness where they're like, what can I do? I'm no one. I'm just like no one. I'm trying to survive in this world. So then don't tell me all this stuff. I can't help you. I can't give you money. I can't change my job. I want to take care of my life. So that's another big blocker towards AI safety, because I think people are, if you talk to them, they'll often agree. They're like, everything you said is correct, bro. Now what can I do? I can't really take any expensive decision that is going to cost me real pain.
Got it. And you deal with heavy jargons day in and day out, right? How do you simplify them for normal audience, or whenever you're talking in your conferences and stuff? Like, I know I kind of asked you to drill down things in a very simplest format, but apart from that, how do you practice to do that?
I think using analogies is very useful. I think metaphors, analogies, that is something that can capture the idea without necessarily relying on a weird word. Then other than that, I try to, if it's easier on a one-on-one basis, when I'm looking at the person talking, I try to see what makes their face light up and find a personal example that speaks to them. Like if they have experience in the field of teaching or in the field of biology, then I can use examples from that field and try to relate AI to that field and explain, okay, how will that impact your domain? Like that really makes it much more relatable. And starting with something concrete really helps. Like instead of starting from abstract and then coming to concrete, you start with something concrete. Pick a real specific example and then zoom out and talk about the general case.
Yeah. You know what happened? I think recently I saw it was a daily soap serial that was going on TV. And I heard the actress speaking about deep fakes on a daily soap serial. And I was like, I don't know if we are hyping up AI too much or if we are underplaying the risk that it comes with. What do you think should be an ideal balance?
I don't think there's any value in worrying about it or hyping it up. Like I think often I would encourage people to look at what can you do? Like the person you can help the most is yourself. Like your choice of when you sleep, what you eat, if you exercise, those things are relevant to your own life. So I would encourage people to think about that more than anything. Like thinking about climate change and AI isn't very useful for most people because they have more low-hanging fruit in their own lives. And that is where your 90% attention should be at. But then you should allocate like some time every year, every 6 months to do a check. Okay, I am doing my stuff right now, but how does my larger life plan work? Next 10 years, next one, am I going to have family? And that's when AI can play a big role in understanding, like not worrying. So worry is not useful. What is useful is to translate knowledge into actionable steps. Like if my friends who think that AI is going to get really good at doing coding or research work, he's making steps to upskill in a different task in order to change careers, or he's looking to join a company which is working on AI safety in order to contribute. So understanding your skill sets, understanding what your skills, gifts you have been given, you're trying to look for how can I be of value to the world? How can I serve? Because if you're trying to give value out, you'll definitely get paid for it. You'll be given status and rewarded. So I don't think worrying or hoping and all those emotions aren't really useful. They just end up trapping you in the state of depression or in the state of anxiety, and you keep going from those two states, and that's not really sustainable. You get burnt out like that.
Who do you think is responsible for AI safety? Is it the AI researchers or the government?
I don't know. I mean, I don't think also there's a separation there. I think researchers are trying their best. I think even government is trying their best. Everyone is having their own pressures, right? Like the government has to appeal to the lobbyists from the companies who are like, hey, if you do all these laws, then we will leave the country. No development will happen. China will make this stuff. So the government is stressed out from all sides. The researchers are also like, oh, I need to get citations. I need to publish papers. I need to become a professor or whatever, or get paid. So everyone has their own motivation. Some of them are, they're curious about doing this research. So responsibility is given to all of us. I think we all have our role to play in this. Just like how, like plastic or climate change, we can't just blame the government or researchers. all of us are enabling the destruction of our rivers or the torture of animals in factory farms. All of this stuff is, I think, we are all collectively paying the price.
What are the kind of policies that we need with respect to AI right now, from your standpoint? Like, what do you think that these policies will either aid in regulated development or maybe controlled development of AI for the better, basically? If in case you were the policymaker for
Yeah.
AI
I'm trying to think of like good ones, but I think there's definitely some transparency norms would be really good. I think there's like a lot of lack of information about who's training which model. So, for example, like Nvidia and AMD are selling these chips to these companies in China or in India or in USA, and having like reporting norms where we all treat it like very seriously. Like if you're doing genetic engineering or creating bioweapons, nuclear weapons, those things are put to a high standard where you need to get certification from the government and you need to have like clear cut policies. Like, okay, I'm being very safe here. I have these safety systems in place so that we don't release a bioweapon into the world. I would think that level of carefulness is required for the frontier labs also, rather than racing forward, because right now everyone is feeling the pressure. Like if you ask them, they're like, we would love to take it slow, but we have to keep releasing products because if we don't do it, they will do
someone
it.
else will.
So Google, XAI, Anthropic, OpenAI, all of them are like racing. And racing is not a good atmosphere to build a safe product. If you have 10 people racing, someone will start cutting corners. So we should really make policies to make sure that no one is racing, then everyone is happy. If no one is racing, then everyone can like put some amount of attention into making sure the product is actually having good outcomes on the people's minds.
That is actually true. And how, I think, what is the role do you think whistleblowers in the field of AI have? Any examples of whistleblowers that you would you'd like to highlight here? But why do you think they're important? And because there should be someone to call out the crap. There should be someone to say, hey, this is incorrect and it's not hunky-dory, right? Give me an example that's your personal favorite when it comes to this entire AI whistleblowing concept. And do you think it's important for the ecosystem to thrive?
Yeah, I think so. One of the reasons I like to go on podcasts and talk about this to many people is because the stakeholders here are everyone. Like your kids, you are also being exposed to these models. Like if you're selling a burger on the street, you need to get permission from the government to make sure it's hygienic, because you might food poison hundreds of people. But when apps are released on the Play Store, it's affecting all of our minds. And we still don't have enough safety regulations there. And the issue is only people inside Meta, people inside OpenAI know the internal metrics. They're like, yes, people are spending 5 hours on this. Or they're clearly seeing a decline in their mental health. So the people in the companies are often, like recently, I think Facebook had a whistleblower where they show that they knew about the impact their app was having on kids on Instagram and things, and they still continue to push. So those kinds of whistleblowers are very valuable in pointing to the company putting profits above their customers' well-being. And it's because the customers are not actually the users. The users are drug users almost. The customers are the advertisers. So in case of AI, there's a guy called Daniel who was working in, I think, OpenAI, and he gave up like millions of dollars of. So usually when you leave the company, they make you sign an NDA, a non-disclosure agreement, which prevents you from talking bad about the company. Now, forget about secrets. That's of course not going to be shared. You can't even say anything bad about the company. But he was like, no, I want to be able to say whatever I believe. I don't want to be put under any such restrictions. And he refused to sign it. And he also told people about the fact that OpenAI was forcing all of their employees to sign this document, which put a lot of pressure on the company, and the company stopped making their employees sign the document, which is very good because then people are talking a lot more about how it happens internally. So I think that's an example of whistleblower being really useful because it can make a big difference before. Otherwise, it's like a small group of people in Silicon Valley deciding the future for all of us. We didn't consent to this. They're building some sort of like super powerful machine god, and we are just going to be able to live with the consequences.
Yeah. And how much coordination do you think is happening globally with respect to AI safety?
I think with the latest administration in the US, it's getting harder the law didn't pass in the California, the SB 108, I think it's called. So there's been like a failure of coordination. It's harder to, because development and AI hype is going up, and there hasn't been a high profile failure of safety in order to make people feel like, oh damn, this is dangerous. Recently there was a case where OpenAI tried to switch off some models, the 4.0 models, and people started saying, no, you can't switch it off. And it literally couldn't be, like people say, it's just a computer server room. Bro, if it's very dangerous, switch it off. What's the big problem? But you can't switch it off, because if you try to switch it off right now, the guards in OpenAI will stop you, the company will stop you, the police will stop you. And even if the company wants to switch it off, the customers will start revolting. They're canceling subscription, they're complaining on Reddit, they're sending emails. And literally Sam had to reopen the model, because so you can't even kill a model anymore. The models are immortal in some sense, because the zombies, the people it talks to, are extremely attached to the model. So they will fight for them. So it's become impossible to kill some models now. So this is an example of like coordination happening across the world and safety, which I think if more of this kind of stuff happen, we might see more, but not enough. I definitely think there's like more value in more coordination happening.
What's happening in India specifically with respect to alignment research in AI? Like how active has it been, and how many folks do you think are working?
There are like labs in IIT Madras, IIT Hyderabad. There are like independent researchers who often work from India. We have like EAGX coming up in Delhi soon, where there'll be a lot of researchers coming and joining in a conference. It's still small because a lot of the people leave the country, because a lot of the training happens in Berkeley, in California or in UK. So they don't stay in India for long. So the community is still very small. If anyone wants, they can reach out to me. I'd love to invite them to more of these events. We posted a retreat happened in Ooty like last month, where we had like people coming in, spending a week diagnosing these models. So I'm trying to kickstart more of a community in India. Right now, it's still very small.
That's very interesting. What is the best case and the worst case with AI would look like in your eyes?
I think the best case, we started the worst case then. I think the worst case in my eyes is more like, it's not like we all die. I think we all get tortured kind of a thing is what I think. Tortured as in, it's not like a physical torture, more like dystopia. You know, you see cyberpunk movies and we play video games. So I would say more of what we're seeing currently, right? Where streets are dirty, it's dark and gloomy, pollution is there. Human beings are less and less powerful in order to make a difference. Our votes don't matter. It becomes the political system becomes more and more harder to change. Like we protest, we try doing all kinds of protests, but nothing changes. And at least right now, they still need us for our economic work. But when it becomes easier to hire an AI system, then they don't care. They just put AI robots to crush you. So we've seen in Hong Kong and like other places where protests don't really work out. So I think the future will look more like that, where it'll be like a slow, gradual disempowerment, where you have an underclass, like how other animals are being, like 2% of the world's animals are like wildlife. Like 80% is like farmed animals, and the rest is like human beings. So we'll have like a larger fraction of human beings being given like a basic income and like rations. I think that's kind of like a future I'm expecting to happen in the next 10, 20 years. I think we'll also see a lot more biohacking and people like modifying themselves. Like just like how we spend a lot of time indoors, it used to be the case that people will not survive indoors. Like we used to spend a lot of time outdoors, spend time with nature, touch grass, where it's very bad for our physical health to spend so much time sitting and coding. So I think that'll again become worse, because the people who are so powerful in terms of economic and political power will be destroying their health, because they will be changing themselves in order to become better at interfacing with these technologies. Like how we becoming extremely losing eyesight and losing our other skills like EQ in order to become good at IQ. The nerds are extremely good at doing math and coding, but they're losing their human touch, their friendships and their love and everything like that. They feel lonely, mental health issues. I'll see extremely more mental health issues will happen, and the people will become cyborgs. They'll become a hybrid. They'll integrate tech into their workflow, like calendar, timer. The entire life will be controlled by their smartwatch, measuring their biomarkers and things like that. I think that's a dystopia.
Okay, best case.
The best case, I think, will look more like beautiful. It'll be like we use AI to.
You need to describe this more.
Yeah, I'm trying to think of how to describe. It's very hard because it's easy to talk about the dystopia because we're already in the dystopia. Like you just have to extrapolate. But the utopia is harder because you got to think a little bit outside the box. The way that at least I think of the utopia. It shows us the ability to be more in harmony with nature, right? Like it's a mirror that allows us to now fix all of the issues we've done so far, like recoup. Like it opens up so much of post scarcity. We don't need to fight over any resources. We don't need to worry about water or food. We have abundance, and we can actually like heal the earth. We can clean up the plastics. We can solve climate change. So we can do things like everyone can become healthy and fit. We don't need to worry about how we appear or how, like already we're seeing some breakthroughs happening in field of medicine. Like the time taken to make medicines are becoming much shorter because AI can help search through possible drug classes. So no one has to be obese. We can have, so there'll be breakthroughs in material science, finding new materials. In biology, there'll be like education. The bar for the worst teacher you will have will be from AI. Like the best teacher will be the best teacher, but then everyone gets access to a personal tutor who's patient and teaching you really well. So your curiosity is being given. You don't have to like watch a movie. They'll make a movie for you based on Harry Potter. Like inspired from all of this content, everyone will get personalized translators, personalized musicians, personalized. So everyone's a king. We all have a personal band creating music for every vibe. We have books written for us. So we are just given so much, just like how we get custom made food. Like we are tasting such fresh. No king had access to grapes and strawberries and all these right now. So we'll get like on the tongue side, we have been given luxuries. Imagine that for everything, like for ears, for skin. So we'll explore the space of tactile feelings. We'll be exploring the space of different ideas. So the future will look like everyone having, not like all the houses and furniture right now is very modern. It's like, oh, it's easy to construct this table and chair and ship it. Everything is based on transportation, weight, cost. But now we can actually let character flow. Your house will be a representation of your fashion. You can build a house that's much closer to your vibe. So that'll look like a beautiful city.
Well, I like the second one better. I think AI is going to be a bigger force than internet and electricity to some degree.
I think so.
The way it's going to impact the world, right? How soon do you think AGI might arrive? If it arrives, are we prepared for that? This is a very open-ended question. Something I had to ask.
Yeah, I think the prediction markets, which are like, there are markets online which bet, people put money on when this will happen. And there are different ways of defining what AGI means. I don't think it will be like a singular point, like, oh, now we have AGI. So a lot of people think it's already happened. Like if you talk to GPT-5 or GPT-4, Claude Code, they're really good. Like they're like polydidacts. Like they know mathematics and physics and philosophy.
Yeah.
I can talk to them about anything and they understand everything. So they're really smart kids, interns. So I think from some definitions, they're already like AGI. The integration of that into society will take time. Like for governments to start giving up power, for companies to hire them and adjust workflow. If you look at computers, initially people didn't know how to use computers. You have to train people to learn how to adjust their workflows to incorporate computers into their life. It wasn't like a plug and play. Like the way you do things is not using computers. So when credit cards came, people were like, checkbooks are how I do things. So every transition took time for it to adapt. And for a long time, even tablets, we still treated it like books. Even though tablets can allow for interfacing and interaction, we still had like journal publication kind of a format. Rather than understanding that hey, we can have dynamic graphs, we can have interactive elements, we can have moving things. So it takes a lot of time for people to realize we can do something new with this new. The fact that we have attention, we have AI at scale is mind-blowing. Yeah. And it'll take at least 10, 20 years for it to really, people to wake up and start using it for their workforce. So I think the real AGI will take 10-15 years, but then the immediate, how do I say it?
Better versions?
Yeah, Amrita Sen said this. Someone said this. Future is here, but it's unevenly distributed. Something like that.
The future is already here, but it's unevenly distributed.
So I think there'll be bubbles of like groups in Bangalore where people will be like living in the future, and you're already seeing it happen. And others in villages, like my grandparents, will still be living in their normal life. So it'll be like extremely uneven.
This was fun, Aditya. Okay, I think a couple questions about your personal journey before we wrap up, right? How did you first get into AI safety?
There was this Turing Prize competition happening in India. There was a group, a person from Columbia and Harvard who came to India to hold a bunch of competitions in different IITs. And when they came to IISc Bangalore, where I was excited. I was like, I love this topic. Like I've been spending my free time reading upon this stuff because I really believe that AGI is a big deal and people aren't seeing it. Because back then GPT-1, 2 had come out and people were laughing at OpenAI. OpenAI was considered to be dumb because they were like, what are you doing? Taking the whole internet? Internet is basically dumb people talking about random stuff, training the entire model on that. Like the model will just spit out random stuff. Like it won't be smart at all. You can't, like DeepMind was doing the cool thing. DeepMind was reverse engineering the brain. But the scaling laws were clear there. Even back then, you could see the model is getting better and better. And I was like, bro, thank you for coming to India, right? We need this. And so they took me with them and I traveled with them to all the IITs. And that's how I got into AI safety because they wanted to like run a competition and I was helpful in the logistics aspect and in explaining the problem to the students. Because I knew the philosophical context to explain what the difference between agent and tool is and what are the specific risks from extinction look like. So that's like 2020, 2021 onwards, I've been like actively working on this topic because of me feeling like, yeah, this is like really important and people are not taking it seriously. They're still considering it from a very, only the misuse risk is what they're concerned about.
Who has influenced your thinking about this field? If there's one or two writers or maybe researchers who you take inspiration from, who are they?
I think Sahil, the person I'm working with, his work is extremely inspiring.
Mm-hmm. Why so?
Why so? I think most people are pretty pessimistic and they talk about the risks aspect a lot. And he was the first person to talk about the fact that to keep up with the risks that come from AI, we need to also look at the opportunities. Like the only way that you can fight fire with fire kind of a thing, where the researchers need to also incorporate AI into their work. Like we need to empower researchers to not just use, like if you're a Luddite, I won't use electricity, but I care about electricity's problems, then you get overcompeted by the people who are using electricity. So there's like an aspect of how do you skillfully use AI for AI safety? Because otherwise people are like, oh, you're against AI. Then how are you using AI? You're a hypocrite. So there's a question of like, oh, people are for AI safety should not use AI at all. And I was able to really see the middle path there where you can look at the new opportunities for a good future, because it's very important to aim for what you want and to offer a good alternative future rather than only put fear into people and be like, no, it's very bad, we're gonna die. That's not gonna help. So I really liked that from him.
That's interesting. Do you ever feel overwhelmed with the scale of problem that you're trying to solve?
I think I did initially for the first few months or year. I've gotten over that within a year. I'm no longer feeling that overwhelmed feeling.
What gives the hope now?
I think it's humility. Like back when I felt overwhelmed, I was actually a bit arrogant to think that I could actually matter in that scale. But it becomes more tractable when you realize that you're not supposed to be. I'm not someone who's gonna actually change the world. If anything happens and I end up saving the world or whatever, it will be because of millions of people like you and everyone helping me. Like to think that I am somehow responsible is very egocentric and selfish. Like every single person who gives me their attention and time, all the viewers, all of the people who are inspiring me, it's actually very much distributed. We are connected to everyone else. So when you recognize the fact that we're all in this together, it's only me, we're all suffering. And we're all understanding this happening. So that gives you like a lot more calmness and groundedness. You're like, oh yeah, this is happening to all of us and we're going to figure this out.
Together.
Yeah. Together, yeah.
What's one idea about AI safety that you wish people understood better?
I think the tool agent distinction is what I think is very important to understand, because most of the past we used to think everything is agent. We're like, oh, the clouds have gods in them, the ghosts are in the air. Whenever you hear some sound, we'll think someone is there. We keep attributing spirits, like, oh yeah, the chair has a spirit. We started going into assigning agency to everything. And then when science came, we started becoming like everything is dead. It's all matter, nothing is alive. We're also machines. So I think people are going extremes into like just assuming everything has a soul, nothing has a soul. And I think those kinds of extreme thinking isn't like the right way. We should be a little bit more open-minded and like calm down and look at what the AI is and notice, is it acting like a predictable tool in this particular context, or is it agent? Is it teaching me what to do? Am I listening to it in designing my logo? How much am I trusting it with my problems, like my decisions on how I behave with my partner or my job? If you start trusting it a lot and you're giving it so much information and it's giving you advice, then at some point you have to recognize it's not a tool, it's more of an agent.
Interesting. How can ordinary people be more responsible with AI today?
Yeah, I think being mindful is key. Being like present and intentional, like being able to.
Mindful in what they're sharing?
I think it's less about what you're sharing and more about what you're trying to get from the model. Like when you're entering into a relationship with any entity, like I know people who have very bad relationship with sugar. Like it's not that sugar is bad. It's more like it's your relationship with sugar that makes it addictive. So you can have, when you're eating sweets, you can be like, okay, I will eat. So like you can, when you're eating the sugar, you can be very present with, oh, I'm enjoying this taste. Oh, I'm actually full right now. No, actually, I'm feeling greedy and I want to eat more. The same way with AI, or scrolling Instagram and you're getting a dopamine hit from these recommendations. If you slow down and like really slow down and like notice your finger moving, notice what you're typing, notice what am I looking for, what am I craving, that can itself be extremely valuable in like breaking out of that trance. And you can be like, oh wait, am I okay with this relationship? Am I enjoying this? Is it good for me? Am I having integrity here, or am I hurting myself in some way? And I think that is very valuable in reorienting the relationship you have with this AI system that you're using.
Very interesting. What advice would you give any young person who would want to contribute in AI safety space today?
Yeah, reach out to me. I think at this point I have a lot of bandwidth to be a mentor. I usually get on video calls with them or chat with them. I point them to some of my resources. So if you want to contribute to AI safety, I think one is to look at what your skills are. Like if you're into communications, if you like to write creatively, there's like scope for people who can create predictions for good futures and bad futures and like map out this landscape, or taking all these complicated ideas and making it more accessible to a wider audience. There's like a lot of work in outreach and communications and marketing. There's work in policy making, like there are organizations like Pause AI, which needs volunteers to help with pushing the policymakers to implement the right laws. So it's like governance solutions that we need people for. If you're into math and computer science and you want to train models, there are a lot of projects and experiments you can actually start coding, running experiments. You can work on evaluations. How do you evaluate particular models? How do you train them to be more aligned? Or if you're into philosophy and more like asking these deep questions, like what does it mean to be having a goal? What is agency? How do I know if the model is deceptive? Is it lying to me? Is it just ignorant? Is it dreaming? Is it hallucinating? All these words, trying to like, if you like working on that space, there's like a lot of scope there also. It's called Agent Foundations. So it's like depending on your skill sets and your interest, there's like a bunch of different areas where you can start contributing.
Any resource material that you would recommend for people before reaching out to you?
I think there's like a lot of stuff, and I usually find that people get overwhelmed when I give them like one or two resources. So it's better for me to like customize and give them specific things. At least in my last few years of trying this out, if you give them one or two links, they might read it. Even that is too much sometimes because the world is like bombarding us with such memes. So if anything, I would say there's a post called The AI Problem by, if you go to intelligence.org, they have a good explanation of the problem. That's like pretty decent. Yeah. Anything else? Like if you want a video there is a rational animations, inside view. These are all places where they have good videos, like more accessible content is being produced online. If you search for Dwarkesh Patel's podcast, he has interviews with many of these researchers where they explain their ideas of how the AI safety is going. I think that will give them a good sense of the landscape.
Interesting. With that, I think I'm done with my long list of questions. Any question that you thought that I would ask today, but I did not?
I mean, there's a lot of questions that you could have asked.
That's part 2, by the way, but yeah.
About AI safety, any question that you should have or could have asked that you didn't ask? Yeah, I think this is a pretty good intro. Maybe time it. Yeah, there is a question about how likely it is that we will go into utopia or dystopia and the probabilities that people often talk about, which you didn't ask, but I don't think it's very important. But I expected that question. I think
But
it's
I
useful.
think we kind of got that answer from the explanations, deep explanations we had for both dystopian and...
More than a number, I gave you like a comprehensive answer.
Yeah.
True.
But yeah, this was very interesting and super technical on a Saturday afternoon. Thank you so much for making time
Thank you for
this.
having me.
Yep, looking forward for more.
See you.